Hello! It is time to start Chapter 12, one of the best chapters of the year about trigonometry. And in the first section, we are mostly going to be reviewing the trigonometry that you learned last year in geometry. So we're going to go through this pretty quickly. There's a few new things, but it's important that you're taking good notes and remembering what you did last year, because there's a lot of information in this section, but it is mostly review. So we're going to be finding the values of trig functions for acute angles, angles between 0 and 90 degrees. And we're going to use trigonometric functions to find the side lengths. We're going to find missing sides and missing angle measures in right triangles. There's a lot of vocabulary in this section, so as you go through, make sure that you are picking that up, making note of it. A lot of these things you should recognize from geometry. All right, trig functions. You mostly learned about these three trig functions last year. If theta, remember this Greek letter is theta. If theta is the measure of an acute angle of a right triangle, then these are the trig functions, and we define them using the opposite side of the triangle from that angle, the adjacent side, and the hypotenuse. So in this triangle, we are looking at this angle, theta. So the sine is the opposite side over the hypotenuse. The cosine ratio is the adjacent side over the hypotenuse, so in this case 3 over 5. Tangent is opposite side over adjacent side, so in this case 4 over 3. Cosecant, secant, and cotangent. These might be new, but notice cosecant goes with sine. Cosecant is the reciprocal of sine. Sine is opposite side over hypotenuse. Cosecant is hypotenuse over the opposite side. Secant goes with cosine. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent. And these ones are easy to remember that they go together, tangent and cotangent. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. So remember in this picture, this would be the hypotenuse, the side that's 5. And based on this angle theta compared to this angle 4 is the opposite side, and 3 is the adjacent side. So that's where they get these 6 trigonometric functions. So that's what we're going to do. We're going to find for this triangle the value of all 6 trig functions for the angle G. So in this case, G is our theta. So it's always a good idea to label if you're not sure what side is which. Remember the side opposite of the right angle is always the hypotenuse. So here 40 is the hypotenuse. Based on angle G, 24 is the opposite side, and 32 is the adjacent side. So we're going to set up our sine, cosine, and tangent. So sine of G, you should be looking still at the picture on your notes. 24 over 40 is opposite over hypotenuse, which reduces to 3/5. Cosine is adjacent, 32 over hypotenuse, 40, 4/5. Then tangent is 3/4, 24 over 32. To get the other 3, cotangent, which we abbreviate as COT, is just the reciprocal of tangent. So if tangent is 3/4, cotangent is 4/3. Cosecant is the reciprocal of sine. Okay, so cosecant goes with sine. Sine is 3/5, cosecant is the reciprocal, 5/3. And then last, secant. Secant is the reciprocal of cosine. Secant goes with cosine. So if cosine is 4/5, then secant is just 5/4. We just take the reciprocal. So here are our final answers for the 6 trig functions for angle G in that triangle. So for this check your progress, I want you to do the same thing for this triangle. Notice we're doing it for angle A. All right, in this case, your answer should be A. Check the labeling of your triangle. When we're basing it on angle A, 20 is the opposite side and 15 is the adjacent side. 25 will always be the hypotenuse. All right, this time we're going to find trigonometric ratios. So here we have a right triangle, and we know that angle A is acute, and we know that the tangent of angle A, knowing that tangent is opposite over adjacent, so kotoa, we're going to find the value of the cosecant. We can't do cosecant right now because we don't know the length of this third side. But what we do know is that I have a right triangle. So here we draw a right triangle. We label it ABC. One of my acute angles needs to be A. So since tangent of theta is opposite over adjacent, I know to label this side 5 and this side 3 because this is my angle A. So 5 is going to be opposite and 3 has to be adjacent since the tangent of A has to be 5/3. So now I need to find the length of C. To do that, I can do the Pythagorean theorem, a squared plus b squared equals c squared. Replace a with 3 and b with 5. So I get c squared is 34, which means that c is the square root of 34. We only take into account the positive square root because we're talking about a length of a side of a triangle, and length cannot be negative. And so step 3 is to find the cosecant. The cosecant is the hypotenuse over the opposite. Remember, it's the reciprocal of sine. And this is what the triangle drawn on your notes should look like now because we found that c is the square root of 34. So if I'm going to find the cosecant of A, I need to do the hypotenuse, which is the square root of 34, over the opposite side, which is 5. So that would be the cosecant of A. Notice, or this is a reminder of notation, capital letters are usually represented, are used to represent the vertices of a triangle or the measure of the angle at that vertex. The side opposite of that angle is labeled with the lowercase letter. So in this case, lowercase a is side A, opposite of angle A. C is opposite of angle C, and side B is opposite of angle B. So that's just a reminder about notation. Okay, try this, check your progress. All right, your answer here should be C, which is square root of 5 over 3. And your triangle should look something like this. Your vertices should be labeled. We usually label the right angle vertex as C. Since the sine of angle B is opposite over hypotenuse, sine SOHCAHTOA, the side opposite of angle B is 2 and the hypotenuse is 3. I use the Pythagorean theorem to find the value of A. Remember that 3 is C and 2 is B in the way that I have it drawn here. 3 has to be C because 3 is the hypotenuse and the hypotenuse is C in the Pythagorean theorem. And when I solve that, I get A is the square root of 5. So the cosine of B is now adjacent, square root of 5, over hypotenuse 3. All right, this might ring a bell or should from geometry. You guys have to know these triangles, the 30, 60, 90 triangle and the 45, 45, 90 triangle. You need to know the ratios of the sides. You have to know this. It's super important for the rest of this chapter. Okay, so if I have a 30, 60, 90 triangle, remember the side opposite of 30 we often call x. The hypotenuse is twice the length of that short side, and the longer leg is the short leg times the square root of 3. So these are the trig ratios for angles 30 degrees and 60 degrees. These are also going to be super important. You're going to use them for the entire unit. A 45, 45, 90 triangle, remember, is an isosceles triangle. So both of the legs, if they have a length of x, the hypotenuse has the length of x square root of 2. And then here are the ratios for the 45-degree angles. We are going to mostly be working with angles that are multiples of 30, 45, and 60 in this chapter that we're going to, when we're finding those ratios by hand, that's why these are so important. These two triangles should be ingrained in your memory. So example 3, we're going to use a trig function here to find the value of x. And we'll round to the nearest tenth if we need to. So in this case, we're given a triangle where my hypotenuse is 12. I don't know anything about this leg, but I do know something about the leg opposite of my 60-degree angle. So if I know something about the opposite side and something about the hypotenuse, that should make me think of sine. Sine is opposite over hypotenuse. So we're going to say, okay, the sine of theta is the opposite over hypotenuse. In this case, the angle we're dealing with is 60 degrees, is x over 12. Now, based on that chart we just looked at with 30, 60, 90, we know that the sine of 60 degrees is the square root of 3 over 2. Again, that's something you're going to need to know or be able to figure out. And now I can just solve. I get, when I cross multiply here, I get 12 times the square root of 3. Equals to 2x. When I divide by 2, I get 6 times the square root of 3. That's my length of x. Rounding to the nearest tenth, that would give me a side length of 10.4. So that would be my missing side. All right, so you guys try that same idea with this triangle. Okay, in this case, your answer should be D. Your most logical trig equation to set up was that the tangent of 60 degrees is x over 5, because based on this angle, x is the opposite side, 5 is the adjacent side. Opposite over adjacent is tangent. You could have done cotangent if you wanted to and done adjacent over opposite. And then when we solve, we know that the tangent of 60 degrees is the square root of 3. And then that equals x over 5. And when we solve, we get 5 times the square root of 3 is equal to x. If I plug that in the calculator to round, I get about 8.7. We're going to move on to talk about inverse trig ratios. This is what we do when we do not know the angle. Okay, so if the sine of angle A is some number, then the inverse sine of that number gives me the measure of the angle. So if I know the sine of some angle, the angle is unknown, is 1/2. If I take the inverse sine of 1/2, I get the measure of the angle. Because what you're actually doing is taking the inverse side of both sides. So when I take the inverse sine of sine, those undo each other. They're inverse operations, and I'm just left with A. When I take the inverse sine of 1/2, I go backwards from this ratio to the angle, which is 30 degrees. You should know that from that list of 30, 60, and 45 degree angles, sine, cosine, and tangent that we had on an earlier slide in your notes. I can do the same thing with inverse cosine and inverse tangent. Be careful with the notation. Cosine, this looks like a -1 exponent, but it is not. When it's attached to a trig function, it means inverse. Just like back in chapter 6, we talked about inverse functions as f inverse of x. This does not mean reciprocal. It's not a negative exponent. It's a notation that means the inverse of a function in this context. Okay, so let's try that. We're going to find the measure of angle A. We don't know what it is. We can't figure it out. We know that a triangle adds up to 180 degrees, but we don't know. We know that this is 90 degrees, angle C, but we don't know how the other 90 degrees is split up between angle A and angle B. So we can set up any trig ratio we want, really. In this case, they're going to use sine. That's fine. So the sine of angle A is opposite 9 over hypotenuse 17. Now I'm going to take, basically what I'm doing is I'm saying I'm going to take the inverse sine of both sides of this equation. Inverse sine of the sine undoes each other, and I'm just left with A is equal to the inverse sine of 9 over 17. For this, you will need your calculators, so make sure you bring them. The inverse sine button on your calculator, when you plug in 9 over 17, should give you about 32 degrees. Okay, so the measure of angle A is 32 degrees, about. Okay, you guys try this one. You're going to find the measure of angle B. All right, in this case, you should have gotten a C, 60 degrees. And your work should look like this. You did not necessarily have to use cosine. You could have used sine or tangent, secant, cosecant, cotangent. I chose to use cosine because when I look at angle B, I see the adjacent side is 3 and the hypotenuse is 6. And I notice that's going to reduce down to a nice fraction of 1/2. So the cosine of angle B is 1/2. I take the inverse cosine of both sides. And that means I'm asking myself, what angle gives a cosine of 1/2? And we should know from our 30, 60, 90 triangles that that is a 60-degree angle. All right, one last thing here in our last minute. This is also a reminder from geometry. Angle of elevation and angle of depression. Here we have a cat and a bird. The cat from the horizontal is looking up toward the bird. That's called the angle of elevation. We always measure it from the horizontal line. So the angle of elevation measures from the horizontal line looking up. The bird, from its horizontal line of sight, looks down to the cat, so that is the angle of depression. And this would be an example of the way we could use it. We have a golfer who's looking up. So here I have a 12-degree angle of elevation. From the tee, where he's starting, to the top of the hole, that angle of elevation is 12 degrees. The tee is 36 yards lower than the green, so I have a 36-yard distance here, and we want to find this x, the horizontal distance. In order to find that horizontal distance, I can use tangent, because based on my 12-degree angle, I know something about the opposite and the adjacent. I set up my equation like this: multiply both sides by x. Divide by the tangent of 12 degrees and use a calculator.